Hey guys, it's Mr. Dugal, and today we're going to talk about making rectangular arrays, which is the next step in factoring. If you are unsure of how to factor, I would stop and watch the video on factoring, as we're going to quickly fly through factoring. And basically, we need to first factor before we can make our rectangular arrays. Factoring is when we list all the numbers that when we write out their multiples hit the number that we're looking for. So in this case, we're looking for all the factors of 24. Any number that has 24 is a multiple when you write out its multiples. So first I have 1 and 24. And this is actually the same exact number, 24, that I used in our previous video on factoring. I know now that the numbers that I need to check for a factor are all the numbers in between 1 and 24. I'm going to just keep going because I'll quickly shrink our pool of numbers. The next one up is 2. And 2 times 12 is 24. The next number I need to check is 3. And when I list out my multiples of 3, I hit 3, 6, 9, 12, 15, 18, 21, 24, and that is 1, 2, 3, 4, 5, 6, 7, 8 multiples. This leaves me with a possible range of 4, 5, 6, and 7 still being multiples. I'm going to check 4. When I list out the multiples of 4, I find 4, 8, 12, 16, 20, 24, and that is 6 multiples of 24, so 4 times 6 is 24. I can cancel 4, 6, and I know it can't be 7 because it has to be a number smaller than the last number on my right side of the U. I go to check 5. 24 does not end in a 5 or 0, so 5 is not a factor. These are now all my factor pairs, and I'm now set to make rectangular arrays. So one array that I could make is one row with 24 dots in it. So this is one array. It's a 1 by 24. This is my next array with a factor pair 1 and 24. This time I have a 24 by 1 array where I have a column of 24 dots. So as you can see, each factor pair will have 2 different types of arrays, and that's kind of how this works. So I should have now 2 rows with 12 dots and 12 rows with 2 dots. Just like so. 2 rows of 12 dots and 12 rows of 2 dots. Next, I'm going to have 3 rows of 8 dots and 8 rows of 3 dots. Just like so. Finally, I'm going to have 2 more arrays. One with 4 rows of 6 dots and one with 6 rows of 4 dots. And there we go, 4 rows of 6 dots and 6 rows of 4 dots. And these are all my arrays that I have for the number 24. Basically, because I have 4 factor pairs here, I'm going to have 8 arrays. I do want to point out this will not always be the case. There is one exception where you would not have 2 arrays. And that is if you have a perfect square involved. In other words, you have the same number multiplied by itself, and we'll do one example like that so you can see that. Otherwise, you should have 2 for each factor pair. Okay, so as I list out my factors of 36, I'm going to start with 1 and 36. I'm going to then check 2. I know that 2 is a factor of 36 because it's an even number and it's 2 times 18. My pool of numbers has quickly shrunk. I only need to check the numbers in between 2 and 18. Next up is 3, and it's 3 times 12, that is 36. I now need to just check 4, 5, 6, 7, 8, 9, 10, and 11. I'm going to check 4, and I find again that 4 is a factor of 36. As I list out the multiples, it's 4, 8, 12, 16, 20, 24, 28, 32, 36, which is 1, 2, 3, 4, 5, 6, 7, 8, 9 multiples of 4. This also means that 10 and 11 could not be factors of 36. I'm going to quickly check 5, but I know that 36 doesn't end in a 5 or 0, so it is not a factor of 36. Next up is 6. And as I list out the multiples of 6, I find that 6, 12, 18, 24, 30, 36 is 1, 2, 3, 4, 5, 6 multiples of 6 equals 36. And I have the perfect square that I mentioned earlier, meaning that 6 times itself is 36, which is going to be a different type of array, and you'll see why here in a second. Okay, I have my first two arrays here. I have a 1 by 36 array on the bottom, and then on the right side we have that same array, but as a 36 by 1. We have both a horizontal and a vertical array. Okay, next I also have my 2 by 18, and then my 18 by 2. Next up I have my 3 by 12 array, followed by my 12 by 3 array right here. Okay, next up I have my 3 by 12 array and my 12 by 3 array right here. Okay, I also have a 4 by 9 and a 9 by 4 array. I also want you to notice in our previous array, when we were writing all the arrays for 24, not only did we have 2 for each factor pair, which so far is the case here, we used dots last time. This time we used X's. Unless the directions tell you what to use for an array, the symbol isn't nearly as important as the accuracy of your factor pairs within your array. Our final factor pair is 6 by 6. I said originally that when it comes to a number where you have a perfect square, it would be a different type of array. And the reason behind that is because up until this point, we have had all rectangular arrays, and 6 by 6 is a square array. So where we have 2 multiple pairs for 1 by 36 and 36 by 1, because they look differently, one would be horizontal and one would be vertical. That's the same for 2 and 18, 3 and 12, and 4 and 9. However, when it comes to a 6 by 6, or any perfect square for that matter, whether it be 5 by 5, 4 by 4, 3 by 3, etc., you're only going to have one array. So in total, we're going to end up having 9 arrays. 2 here, 2 here, 2 here, 2 here. That's 2, 4, 6, 8, and then 1 here to make 9 total arrays. Here's my final 6 by 6 array. Again, this is only going to be one way, and it is a perfect square, and it is my final array. So here are all my arrays for 36. Again, I'm always going to have 2 arrays for each factor pair unless I have a perfect square involved. Then I'm going to end up having only 1 for that perfect square and an odd number of total arrays. Otherwise, I will have an even number of total arrays. So I have 9 arrays total in this case. 1, 2, 3, 4, 5, 6, 7, 8, and 9. 2 of each and 1 for my perfect square. That's about it for rectangular arrays. Hopefully this helps connect 2 factors. Thanks so much for watching.